Hello friends, welcome to Gradeup. My name is Vikas Vadoria. Okay, and today I'm going to start with a new subject of mechanical engineering, which is heat transfer. Okay, all right. Now you must have studied this heat transfer in your BTech of mechanical engineering, and this is a very good and easy subject. And if we talk about with respect to different competitive exam like GATE exam, SSC, JEE exam, or engineering services examination, this subject of heat transfer is a very easy subject. If you are well versed with the concept and formulas, okay, then you can definitely solve all the questions regarding this subject heat transfer. Okay, so I'm going to start this video tutorial on this subject of heat transfer. Okay, and I will try to cover the entire syllabus of the GATE exam of heat transfer. Okay, and in which along with the concepts and notes I will solve some previous year GATE questions on heat transfer. All right, so let us start with this subject. Now if we go through the weighted analysis of the heat transfer, I have done a weighted analysis of previous year GATE questions, and what I have analyzed is that this subject heat transfer is asked in the GATE exam with a minimum of 3 marks and maximum of 11 marks. Okay, so in 2018 it was asked in 3 marks, all right, and 17 it was asked in 5 marks. So if we take an average, so it is asked from 4 to 5 marks questions are from heat transfer in the GATE exam. Okay, and I'm telling you that those questions are very simple, very easy if you are well versed with the formulas, concepts and notes. Okay, so I will try to cover this entire syllabus of heat transfer, and I will make sure that you at the end of my video tutorial you will be very confident about this subject, and you will score really good in this in GATE exam, and you will get those 4 to 5 marks. Okay,
subscribe to our channel and press the bell icon to never miss any update from Gradeup.
Now let's see what is the syllabus of heat transfer and from GATE. Okay, so in the syllabus you will be studying about modes of heat transfer, in which you will be studying about basically conduction, convection and radiation. Basically there are 3 modes of heat transfer. Modes means the mechanism in which the heat transfer can take place. So there are basically 3 modes: conduction, convection and radiation. Then you will be studying about one-dimensional heat conduction equation, that too in Cartesian coordinate, Cartesian, cylindrical and spherical coordinates. Okay, so I will tell you the equation of one-dimensional heat transfer in Cartesian coordinate, that is x and y coordinates, okay, cylindrical coordinates, okay, and spherical coordinates. Okay, now I will next topic is heat transfer to fins and unsteady state heat conduction. This is also very important topics, because from fins and unsteady always there is at least one question from this topic, either from fin or from an unsteady heat transfer. Okay, so these are very important topics. Now next is free and forced convection heat transfer. Now free and forced convective heat transfer is also a very important subject, because convection is another mode of heat transfer, and from this also at least one question is from free or forced convection, either from free convection or from forced convection. Okay, also there is a topic called heat exchanger performance. Okay, now heat exchanger, as you all know, is a device which is used for heat transfer. Okay, and this you must have studied in power plant engineering. We also in refrigeration, air conditioning, that the types of heat exchangers are condenser, evaporator. Okay, these are all types of heat exchanger. Okay, also boiler is a kind of heat exchanger. So these are some example of heat exchanger, and we are going to study this heat exchanger, and we will try to design this heat exchanger by finding the area of the heat exchanger by 2 methods called LMTD method and NTU method. Okay, so there are 2 methods which are used for design of heat exchanger to find the area of heat transfer of the heat exchanger. Okay, And the last topic is radiative heat transfer or heat transfer by radiation, in which we are going to study the loss of radiation. Okay. Along with that, you will also study about view factor, and in the end you will be studying about radiation network analysis, in which we will be studying heat transfer through radiation through different parallel surfaces or through two surfaces in which one surface is kept inside another surface. Okay, so we will be studying radiative heat transfer through network analysis. Okay, heat transfer of through radiation through network analysis, in which we will be studying about a radiation shield. Radiation shield are basically used to reduce the rate of heat transfer by radiation. So we will be studying what will be the effect of shield. Shield is a type of covering which is used to reduce the heat transfer. Okay, so we will study the effect of a radiation shield on the heat transfer by radiation. Okay, so these are some topics that I will be covering in my video tutorials on heat transfer. Okay, and I will be covering the entire syllabus of heat transfer from GATE point of view. Okay, and along with these topics, I will be also solving some previous year GATE questions from these topics. Okay, so that you will be understand that how I am going to apply this concept after going through those topics, how I am going to apply this concept to solve some previous year GATE questions. Because the important thing is that after going through the concept, you should understand how to solve questions. So what should be the approach? But I am telling you that for heat transfer, there you can directly apply the formulas and you can get the answer. Okay, because if you are well versed with all these topics, you can easily solve question of heat transfer, because that's not a that much tough subject. Okay, so if you talk about books and reference book for this heat transfer subject, there's a book by Indian author from Fundamentals of Engineering and Heat and Mass Transfer. This is a very good book by R.C. Sachdeva. Okay, and if you want to refer to the book, you can refer to this book by Indian author, and to solve some more questions or practice or go through some concept into detail of the concept, you can refer to this book by Indian author R.C. Sachdeva. Okay, next is a good book by J.P. Holman. This is a very good book, and you can also refer to this book by J.P. Holman and Souvik Bhattacharya if you want to again go through some numerical go through some live example and also solve some more numericals. Okay, along with solving previous year GATE questions and practicing some test series, you can, if you want to practice more and more, you can go through this book. Okay, by J.P. Holman and Souvik Bhattacharya. And if you again want to refer to some foreign author, there is a good book by foreign author Frank B. Incorpora and David P. Devitt. Okay, this is also a good book, and where you can give lot of live example, okay, and theoretical concepts. Okay, so these are some important books if you want to go into the detail of the subject of heat transfer. If you want to make get more into the depth of the concept, then you can refer to this book. But for GATE point of view, this is come from between 4 to 5 marks. So for these 4 to 5 marks, I urge you that you should go through some video lectures. Okay, and as I am trying to cover all this syllabus of GATE exam from heat transfer from GATE exam point of view, so try to go through the video tutorials. That will be enough, more than enough for you, because in the heat transfer, if I talk about heat transfer, to solve those previous year GATE questions or to solve GATE questions of heat transfer, you just need to go through you just need to have a not too much detail knowledge about the subject. That detailed knowledge is good if you want to go for some interview or so, for engineering service examination. For GATE examination for this particular subject, heat transfer, you should go through some all those topics of heat transfer, and you should cover the entire syllabus. So in my video tutorial, I am going to cover the entire syllabus of heat transfer from GATE point of view. And after going through the video tutorial, if you are going to practice questions, I guarantee you that you will definitely perform well in the GATE exam. Now, what is heat transfer? Friend, I have also covered video tutorial on thermodynamics, and in the introductory video, I have told you the difference between thermodynamics and heat transfer analysis. Okay, if you remember and if you have gone through the video tutorial, I have told you that what is the difference between thermodynamic analysis and heat transfer analysis. Let us take example of a tube light. Okay, now if you see a tube light, what you will see that when you push the button and to switch on the tube light, what is happening? Electrical energy is getting converted into light energy or heat energy. Okay, so in thermodynamic analysis, what is happening? The electrical energy is transferred from one equilibrium state to another equilibrium state of heat energy. Okay, and how much heat is transferred is the main criteria in thermodynamic analysis. Okay, now if we talk about heat transfer analysis, what is in terms of heat transfer, what is the difference between thermodynamic and heat transfer analysis? So if we take again the example of a tube light, so in heat transfer analysis, we will be interested to know that at what rate heat is being transferred from tube light to the surrounding, at what rate. So my friend, rate of heat transfer is studied in heat transfer subject. Okay, and thermodynamics will be only studying about how heat is getting transferred, okay, from one equilibrium state to another equilibrium state, but at what rate. But that means with respect to time, how much heat energy is getting transferred. That is the criteria in heat transfer analysis. Okay, but in thermodynamics we are not concerned about the time at which or at with what respective time how much heat is getting transferred. Okay, all right. So if we talk about, for example, taking the example of a tube light, we will be interested to know that heat is getting transferred and that heat transferred is equal to 10 kilojoule. Okay, is the amount of heat which is getting transferred. But if we talk about heat transfer analysis for a tube light, then it will be 10 kilojoule per second of heat is getting transferred from tube light to the surrounding, and that is 10 kilojoule per second. So with respect to time, what is the amount of heat transfer, okay, from one equilibrium state to other, that we are going to study in heat transfer analysis. Okay, now this was a difference between a thermodynamic analysis and heat transfer analysis. I hope you have understood that. So in particularly what you have understood in thermodynamics, that for heat transfer to take place, what is the main thing that we require? We require a temperature difference, because until and unless there is no temperature difference, no heat transfer can take place. Okay, so for heat transfer we require a temperature difference. So if there is no temperature difference or temperature potential, no heat transfer can take place. Okay, so flow of heat requires temperature difference, and that is called temperature potential. Okay, so this is the one important thing. Now, how heat transfer will take place? Okay, heat transfer take place according to Clausius statement of second law of thermodynamics. So in second law of thermodynamics, we have studied two statements. One is Calvin-Planck statement, in which we have studied the concept of heat engine and heat pump. Okay, and in Clausius statement we have heat engine. In the Calvin-Planck statement we have studied the concept of heat engine. Okay, and in Clausius statement we have studied concept of heat pump and refrigerator. Okay, and in that what we have studied, that it is not possible to transfer heat from a low temperature device to high temperature device until and unless there is some external work is applied. So to transfer heat from a low temperature device to high temperature device, we required some work. But what happens naturally is heat transfer always takes place from high temperature source to low temperature source, and for that we don't require any work, only temperature difference is required. So if there is some temperature difference, suppose that there are two blocks, block 1 and block 2, okay, and suppose that this block is having temperature of suppose that this is having temperature of 60 degrees Celsius and this is having 30 degrees Celsius. So if there is some temperature difference between two blocks and these are kept in a closed vessel, okay, So heat transfer will naturally take place from this high temperature block to low temperature block, and it will not require any work. Okay, so the temperature difference is 30 degrees Celsius. Suppose that after some time this temperature difference reduces to, these blocks almost come to same temperature difference, 10 degrees Celsius, 10 degrees Celsius. Okay, so that means temperature difference is equal to 0 degrees Celsius. So if temperature difference is not there, there will be no heat transfer. So for one important thing that is required for heat transfer is temperature difference or temperature potential. Okay, so that is the main criteria for heat transfer. Okay, and that criteria comes from Clausius statement of second law of thermodynamics. Okay, now let us understand this heat transfer with the example. Suppose that there is a block which is having some temperature of 90 degrees Celsius. Okay, now this block is been immersed in a reservoir which is having some water, and the temperature of water is equal to 30 degrees Celsius. Okay, now what will happen? Tell me. From Clausius statement of second law of thermodynamics, since the temperature of this block is 90 degrees Celsius, as soon as this block is dipped into this reservoir, what will happen? Since the temperature difference, there is some temperature difference of 60 degrees Celsius, heat transfer will take place. Okay, now what will happen? As soon as this block will come into contact with this, now block will be here. Okay, as soon as it is in contact with this water, heat transfer will take place from Clausius second statement of second law of thermodynamics. Heat transfer will take place from block to the water. So what will happen? Block temperature of the block will get reduced. Okay, and temperature of water will increase, and this will happen by first law of thermodynamics, that energy is conserved. That energy always, total energy of system is conserved, it gets transferred from one form to another. So if by Clausius second law of thermodynamics, this block is losing heat to the water, okay, and the amount of heat that this block is losing will be gained by this water, and this is from first law of thermodynamics. Okay, so this first law of thermodynamics is also called as law of calorimetry. Okay, so from this law of calorimetry, we can find the temperature of final temperature of this block and also the final temperature of this water. How we are going to find it? So from first law of thermodynamics, the heat lost by steel block will be equal to heat gained by water. This is from first law of thermodynamics, that total energy is conserved. So the amount of heat which is being lost by this steel block which is having higher temperature, okay, so it will be gained by water. Okay, so this heat lost by the steel block will be equal to m mass of water into Cp of water into temperature difference. Now temperature difference, as you know that the steel block will, the temperature steel block will be get reduced. Okay, so which is having some higher temperature, suppose it is having temperature of 90 degrees Celsius, so temperature of steel block will reduce to some final temperature of Tf, suppose that. Okay, now the heat gained by the water will be equal to m Cp of water, here is Cp of steel block, Cp of water into this water will gain some heat. Okay, and as soon as it will gain some heat, it will take this extra temperature. Okay, the temperature of water will increase, so the final temperature of water will be more than the initial temperature. Okay, so by this you can find the final temperature of the steel block and water. Okay, and this take place due by this equation is written from first law of thermodynamics. Okay, so this is the complete scenario of heat transfer. So for heat transfer to take place, what we have understood, we require some temperature difference. Okay, and if there is no temperature difference, there will be no heat transfer. So what we are going to study in the next video lecture, we are going to study that what are different modes of heat transfer. Okay, so basically we will be studying about conduction, convection and radiation. So these are three modes of heat transfer, and what is the difference between these three modes of heat transfer, okay, and how these modes of heat transfer are different if we talk about respect to solid, liquid and gas. Okay, so this was our today. Today I have given you just an introduction of what is heat transfer along with the weightage analysis for GATE exam and the reference book. In the next video lecture, we will be starting with the modes of heat transfer, and we will be studying about conduction, convection and radiation. Okay, so this is all for today. Thanks for listening. Have a nice day. Thank you.